Hello and welcome to Double Displacement Reactions, specifically the Solubility Table by Dina Ciccone. As with each presentation thus far, I would ask you to stop each slide and take the notes that you think you're going to need and be prepared for class tomorrow. What we're going to talk about today is why some reactions occur and others do not, with respect to double displacement reactions. To determine this, we use a handy tool called a solubility table. I have given everyone their solubility tables, and while we're doing this presentation, I would like to have you to have it out in front of you so that you may take the appropriate notes on the table. So pause the screen and please go get that. Okay, some of the signs that a chemical change has occurred. Keep in mind these are just a handful. This is not a comprehensive list, just the ones that we are concerned with in our classroom. We have bubbles appearing, which indicates a gas is forming, a temperature change, a color change, and a precipitate. Remember that a precipitate was a solid coming out of solution. Actually, on the next slide, I'm going to show you some precipitates that we've done in the classroom. Okay, looking at your double displacement, the general form of the reaction, we've got AB plus CD yields AD plus CB. In order to say that a reaction has occurred, we're looking for a few things. We're looking for precipitation reactions, neutralization reactions, which we will talk about at a later unit, and gas-forming reactions. Gas-forming reactions occur only with decomposition reactions, and that will produce a water and a gas. I will show you what I mean on the solubility table. If you remember this picture, this was from our ionic compounds lab, and what you did was basically each one of those was a double displacement reaction. You had ionic compounds in solution, and you put a drop of each, and you watch the ions switch places. Okay, on the top of your solubility table there's a key, and I would just like to expound on this a tad bit. We have a capital S for soluble. What that means is something is in solution or aqueous. We know what aqueous means because we've been using it this entire unit. SS means slightly soluble, but for our class as well as for AP, we will just consider that it's also soluble and aqueous or in solution. What that means is we're not seeing a precipitate forming. I is insoluble. That means that a precipitate is formed and that we have a chemical reaction occurring. A means soluble in acid but insoluble in water. So if something is soluble in acid, that means it goes into solution, but in water it does form a precipitate. And D decomposes into a water and a gas. Let's do an example. First thing, again looking at our general equation, notice all we've done here is that the A and the C have switched places. Well, here I've got two ionic compounds. My A and C here are silver and sodium. I want to switch places, but the first thing I'm going to have to do is split those ionic compounds into their individual ions. So here I've got silver with a positive 1 charge, nitrate with a negative 1 charge, sodium with a positive 1, and chlorine with a negative 1. So if I go ahead and just switch places, Ag and sodium, I end up with sodium nitrate plus silver chloride. Great. But here's the problem. I don't know if that's actually a real reaction or not. So what I'm going to have to do is I'm going to go to my solubility table, and I'm going to look up sodium and nitrate and see if it's soluble or insoluble or a decomposition reaction. So let's do that together. Sodium and nitrate. First thing I'm going to do is I'm going to locate sodium. Notice on the left-hand side, these are your cation. So here's sodium. And on the top, these are your anions. I'm going to find nitrate. Great. Then I'm going to come down the row to where they meet. Oh, that means that it's soluble. So that's not going to form anything, sodium nitrate. Well, let's go back. What was our other compound? Oh, silver chloride. Okay? Do you think silver chloride is going to form a precipitate? Let's find out. We're going to use our handy dandy table. I'm going to change this to green. I'm going to find silver. Oh, there's silver right there. And chloride. And I'm going to come down the table. Oh, insoluble. So, one of my products is soluble and one is insoluble. So what this means is that this reaction will occur. So sodium nitrate is soluble and silver chloride is insoluble. So this insoluble compound is going to form a precipitate. So yes, indeed, a reaction has occurred. Let me go to my next slide and we'll summarize the types of reactions. Oops, the next one. Here we go. In order for a reaction to have occurred in a double displacement, at least one product must be insoluble or decomposes. If both of the products are soluble, then no reaction has occurred. They're both in solution, you're not seeing anything. This is the end of the double displacement solubility table. Please make sure that you took great notes on this because tomorrow you're going to prove to me what you learned today. Until next time,